Welcome everyone to the second week of the MOOC Designing Climate Neutral Industry and Electricity Generation. During this week you will learn about methodologies and tools to mitigate greenhouse gas emissions inside and outside the boundaries of the industrial plant. My name is Gijsbert Kodevaar, and in this week, together with Samantha Tanser, Mar Perez Fortes, we are going to drive you through the CO2 mitigation measures in the industrial sector. My academic and professional background is in sustainable chemical engineering. One thing that I discovered in the past 20 years of my career is that it is rather difficult, or perhaps even impossible, to define the sustainability of one single industrial operation. And therefore I will show you in this week the system perspective that is needed to work on an integral industrial energy transition. In week 1, we emphasized the importance of technologies for the energy transition. In week 2, you will learn that also other aspects are important for the necessary transition that our society and its industry must make. In sustainable development literature, 4 levels of system change are distinguished for a successful transition to a sustainable society. The levels go from 1, process change, via 2, product change, and 3, organizational change, to level 4, system change. In this video I will explain you more about the relation between the second and the 4th level of system change. Each operation or company is part of a larger value chain of actors and consumers that go beyond the responsibility of the individual plant management. Such a value chain can be assessed with the tool of life cycle assessment, in other words LCA, which is part of level 2. My drive for sustainability and the challenge to make industry more ready for the 21st century have led me to teach about and do research on the concept of industrial ecology. And this is denoted as IE in the figure as part of level 4. You can see here the explanation of what all the terms and abbreviations mean in this figure. They relate to tools and methods that are quite common in the field of sustainability and energy transition, and more information can be found in literature. An example of LCA will be given in the next video of this week. The larger system perspective on industrial ecology places the engineering aspects besides other non-engineering issues and offers a structural insight with regards to the allocation and problem decomposition of those various issues. Industrial symbiosis has been one of the pillars in the field of industrial ecology since it started in 1989. And this is nicely presented in this figure by Yap et al. From 2016. Industrial ecology provides insights on how to integrate industrial operations of distinct companies and other surrounding activities for a better environmental performance. Industrial ecology is not only an engineering concept, but also links to the core of business making in terms of resource efficiency, energy performance, and environmental impacts. Industrial ecology can also deal with aspects on higher company levels and embraces corporate social responsibility and vision deployment. In this way, industrial ecology also relates to concepts like circular economy and sustainable growth. Challenging questions from level 2 till level 4 dealt with LCA and industrial ecology are, for example, how can firms ensure their long-term environmental and sustainability performance? How can they ensure their license to operate in the light of changing user needs, technological innovations, changing economic conditions, new societal preferences? And how can firms shape system change and develop robust investment strategies to support nature, society, and the economy today and in the future? In nature, several types of symbiosis are seen. Some of them result in a positive mutual benefit. Others are more like parasitism. In this nice picture of a crocodile and a plover bird, we see a natural example of mutualism. The bird helps the crocodile to clean its teeth, and in return, the crocodile does not mean any harm to the bird. In the field of industrial ecology, mostly the collaborations are defined as mutual benefits. And however, it's fair to say that also other forms of symbiosis can be found while studying industrial interconnections. In terms of analysis, we could say that we can see various forms of symbiosis. In terms of design, we strive for mutual benefit. And this idea of taking nature as a metaphor is key to the concept of industrial ecology and also industrial symbiosis. The natural inspiration can help us to find solutions that go beyond the typical engineering approaches. Key aspects of industrial ecology include the typical notions of environmental engineering, like reduced environmental impact and improved resource efficiency. These can be studied nicely with life cycle assessment. And this is also to emphasize that we're not talking here about just industrial collaboration, but we are looking for a clear focus to achieve sustainability within that industrial collaboration. Industrial ecology will also lead to a more integrated energy policy by heat integration or energy management, by which carbon emissions reductions of the industrial region can be achieved. And this can be checked and evaluated by the tools and technologies that we discussed in week 1. Industrial ecology also brings an improved way of stakeholder involvement, both local community that lives near the factories as the consumers that are affected by the products. Corporate social responsibility will make the production more sustainable and affordable, and since industrial ecology is about industries that work together, a shared sustainability vision and shared strategy are also essential. Industrial ecology heavily relies on the idea of infrastructure design. Industrial clusters, industrial region development, industrial networks, all these concepts require an understanding of how an integrated infrastructure should be designed. And the design of infrastructures concept considers the technological behavior of engineering networks, but also the societal and economic behavior that is intertwined with technology. There are technological challenges that must be met, but in addition, sustainability depends on the institutional behavior of the network. Integrated industrial systems can be described as networks of technology interacting with networks of actors in complex ways through institutions. The possible connections through industrial ecology can be of various kinds. Together with the engineering consultants of Bilfinger Theebodin, we did a study into 164 cases of industrial symbiosis in the Netherlands. And as this figure shows, the most dominant type is byproduct exchange, also known as the idea of waste equals food. But we also saw several types of utility symbiosis and utility exchange, in many cases steam or hydrogen networks. And this is especially important for the energy transition. The co-siting, being the idea of diverse types of companies that share the same lot in the industrial region, is also seen as a kind of industrial symbiosis. And industrial symbiosis is not only about the physical flows, but also about information and vision sharing. In this video, I have explained how system thinking, and especially life cycle thinking, and industrial ecology are concepts that build upon the other levels of sustainability. It integrates analytical and design tools to evaluate the sustainability of integrated industrial networks. And it also connects sustainable business creation, environmental management, and corporate social responsibility. Thank you for your attention.